Hello everyone, my name is Joe White. I'm the CTO at Entondo, and thank you for coming to our presentation today on breaking up the Monolith, a micro-frontend application architecture for Kubernetes. The presentation today will be focused on how Java and Kubernetes are key enablers for creating a modular architecture using micro-frontends. We'll start with a quick introduction to micro-frontends as a technology and the value proposition of a micro-frontend architecture. We'll follow that by understanding how Kubernetes provides key features for delivering on micro-frontends. Then we'll take a look at how Java and Quarkus in particular can accelerate application development and delivery for micro-frontends. Finally, the presentation will provide some best practices to think about when building your micro-frontend architecture. As we go through the presentation today, I'll show a sample micro-frontend application deployed on Kubernetes. At the end of the video, I'll provide a link to the source and instructions for downloading and installing the app on your own Kubernetes cluster, so you can see how we built and deployed this application using Kubernetes, Java, and micro-frontends. So before we go too far, we need to understand exactly what are micro-frontends. A micro-frontend is a small, loosely coupled, self-contained code base that can be independently tested and deployed as part of an application. It's important to understand also that micro-frontends are usually composed into a final application for presentation to the user. The user experience isn't changed because you're using micro-frontends, but you use micro-frontends to create a more dynamic and changeable experience from an operational and delivery standpoint. Micro-frontends are also built and delivered using standard technologies like web components or single-page applications, and we'll talk a little bit more about that as we look at some code later on in the presentation. Micro-frontends have also received a lot of attention in the general industry. So ThoughtWorks and Martin Fowler have marked micro-frontends as a technology that's ready for adoption, and we're starting to see a lot of companies and big industries adopt micro-frontends as a way to deliver more modular, adaptable applications to their end users. And more recently, about 24% of developers have used micro-frontends, and that number is increasing in the industry as a whole, as we seek to break up kind of the front-end monolith that exists in a lot of applications today. And as we talk about the front-end monolith, you can really think about the full stack application evolution lifecycle. If you start over here on the left with the monolith, everybody's familiar with this. You have a single application server, you have a single application, everything's together, everybody works in a common code base, and then it's deployed all at the same time. That sort of led into SOA and service-oriented architectures where you break things apart into different services. Maybe your front end is still coupled to your back end, but you've started to break things apart. And then more recently, everybody here, of course, as being attending a Kubernetes conference, is familiar with microservice patterns. And you've got your microservices, your API gateways, your deployment into containers and Kubernetes, things like that. But in a lot of cases today, there's still a front-end monolith here. There's still a very large JavaScript application or a very large front-end application where everything is deployed together, and then it's communicating with these small modular pieces of functionality on the back end. And the goal of micro-frontends and the goal of a micro-frontend architecture is to extend that same value proposition out to what you do on the front end. So you can have a set of micro-frontends that are composed into an application that's presented to the final user that communicate with a set of microservices on the back end. And the microservices they communicate may be BFFs or backend for front end, which we'll talk about that pattern a little bit later in the talk, or you could communicate via an API gateway. So you can build dedicated pieces of functionality that are full stack, or you can build fully decoupled user experience and microservices on the back end. And really, as you think about how containers are deployed and how microservices are deployed, this is a pattern that really creates a modular, extendable, and adaptable architecture as your business evolves. So let's talk a little bit about the goals of a micro-frontend architecture and why you might adopt a micro-frontend architecture. One of the main goals is to create team independence and to create mission-aligned teams. With a micro-frontend architecture, you have the ability to assign front-end capability and back-end capability in the form of microservices to a group of people or to a team, and then allow them to evolve and deliver that capability independently. Just like with microservices, you create kind of loosely coupled API or contract-driven teams where you have the ability to define a domain or define a set of expertise and allow them to evolve and deliver independently. So in this picture, you can see, this might be our final application with a little bit of red, which is our account login, a little bit of blue, which is product recommendation, gray, which is our checkout team. And each of those teams has the ability to evolve and deliver independently using micro-frontends and using microservices. And then they can update their applications with minimal impacts to other teams or minimal impacts to testing. You still have to test your applications, but you're testing contracts and you have the ability to enforce the way those applications are built and deployed. So one of the main benefits of micro-frontends is creating teams that have a focus on a particular mission and then giving them the ability to evolve and release independently. Another benefit of micro-frontends is your teams can use the tools that they already use. So if your front-end team is already using Vue, Angular, React, whatever the case may be, those are compatible with the micro-frontend architecture. The architecture itself does not impose on you a technology choice. There are still things you have to build, and there's still choices you have to make, but you can use the tools and capability that you've already got in your system. And then the last real big benefit that we'll talk about here is the ability to reuse components across multiple projects to standardize the way you interact with your enterprise, the way you interact with your backends and things like that. So micro-frontends are built to be portable because they have that contract or API-driven approach built into the technology and built into the architectural design. Just like with microservices, the goal with microservices is to expose a contract or a set of capability that you can reuse with minimal changes. And the goal of micro-frontends is to take that same concept and extend it to the front end. And then there are technologies and capabilities in the web component spec and in the modern JavaScript frameworks that make that relatively easy to do as you build your applications. So with all of those benefits in mind, let's take a look at a practical example and look at some micro-frontends in action. As you can see here on this layout, you have a UX design that identifies a set of capability that you need to deliver to your end user. And then your goal is to use micro-frontends and microservices to deliver that capability in a modular way. So for example, we have an alert icon, we have a sign-in widget, and then we have some static content or content that we want our user to see as the main part of the page. When that's realized in a micro-frontend architecture, potentially, your alert widget is a single micro-frontend. You have some capability delivered to sign in via micro-frontends, and then you have Vue or other capability that you want to show to your end users, and then that communicates via an API gateway to your microservices. So with this design in mind, let's pull up an example application and see what this looks like to the end user when we've built our micro-frontend application. As we go through the presentation today, I'll be showing you the seed bank demonstration application. This is an application that we use to demonstrate how Kubernetes, Java, and micro-frontends can be used together to deliver a really dynamic user experience. I'm going to navigate to the dashboard. And the dashboard is an example that we use to talk about how micro-frontends work. And so the sign-in widget that you saw was an example of a micro-frontend redirecting to an identity management system. The boxes that you see, the checking, savings, credit card, these are example micro-frontends that are configured to use different data sources for the same micro-frontend. So you can take a single micro-frontend and reuse it multiple times on the same page and drive different data into it via configuration. And then this transaction system is another example of a micro-frontend. As we go through the presentation, we'll dive into the details, look at how these are implemented and where the data comes from. And we'll also jump over into OpenShift and take a look at how these are deployed and managed from a backend and Kubernetes perspective as well. But the goal is to deliver an experience like this, using the power of Kubernetes, using the power of Java, and then micro-frontends to serve that capability in a modular way to the end user. The last topic we'll cover before we dive into Kubernetes and Java as enablers of our architecture is how micro-frontends are built. What are the technologies and decisions you have to make as an architect to create an application that uses micro-frontends? So when you're building micro-frontends, there are three common ways or three common approaches that you can use to develop and deliver your micro-frontends, all with their pros and cons. The first one is to use web components. And the pros of web components are that they're open, well understood, and you can really clearly define contract-driven communication between different parts of your application. The downside is that it requires composition, so either you need to use a platform that gives you that composition, or you have to create one yourself. And then it also requires a little bit of knowledge and training to build, but you can use standard tools and capabilities. So all of the modern JavaScript frameworks support web components. And as we get into the example application and take a look at how some of these are composed in an Intondo application, web components are the choice that we've made to use inside of our company for delivering our micro-frontend applications. You can also use iframes. Iframes provide some benefits in terms of strong independence and clear isolation, but we find that they're a little bit more difficult to integrate. They're not as flexible, and it's harder to route and link between them. There are some very large implementations of micro-frontends that use iframes and very successfully. So it depends on what you're looking for. And then the last one is to do kind of JavaScript-based integration using single-page applications. This is highly flexible, and again, you can do this with the standard frameworks that are out there. It can be more challenging to standardize your approach, and you have a little bit more risk of tight coupling depending on how large you make your single-page applications and how you integrate them on the final page. A micro-frontend architecture also gives you the ability to use multiple frameworks per application, or even multiple frameworks on the same page inside of a given application. If you're starting from scratch, I wouldn't recommend that you set out to use multiple frameworks on the same page or even in the same application. It's better to standardize if you can. But having the ability to integrate multiple frameworks can provide a lot of flexibility if you're consuming capability that was built outside of your company, or if you're migrating from one framework to another. Having a modular micro-frontend driven architecture gives you the ability to kind of pick and choose or to reuse capability that you might not otherwise be able to inside of your front-end application. And as we look at our sample application here in a moment, we've created an example of using a React and Angular micro-frontend on the same page just to demonstrate how that looks and feels to the end user. Another common question with micro-frontends is how they can communicate with one another, how you can provide a seamless user experience from a data perspective when you're building modular or independent pieces of functionality on the front end. We recommend using custom events from the web component spec to emit and consume data in micro-frontends. There are other approaches like using Redux stores if you're building a React application, or using query parameters to pass data between micro-frontends. But if you use custom events, you have the ability to treat the DOM as an API and emit and share data between your micro-frontends. And that's what we'll show when we get to the sample application, is how you can use that type of communication structure to pass data from one micro-frontend to another and maintain that decoupled state across multiple micro-frontends. So with that in mind, let's jump back over to our sample micro-frontend application and take a look at the dashboard and how we realize these micro-frontends from a technological perspective. As we mentioned, there are 3 micro-frontends here and then one for the table of data below. 2 of these micro-frontends are built using React and one is built using Angular. We did this just to demonstrate that you can put different technologies on the same page and create a seamless user experience. Again, if you're starting from scratch, you don't want to set out to do that, but you do have the ability to mix and match frameworks as you need to. These micro-frontends also communicate via custom events, which we just talked about from the micro-frontend communication standpoint. So if I click on the checking box or the savings box, the transactions below update based on the section of the application that I've chosen. So this micro-frontend is emitting a custom event into the DOM that's consumed by the table micro-frontend below that updates the data that you see for the micro-frontend itself. So even though these are modular, independent pieces of technology, they have the ability to communicate with one another and trigger changes in the application that are relatively seamless to the end user. So if we log into the administration area of this application, we can take a look at how the micro-frontend itself is built using a custom element. In this case, we'll log in, go to the micro-frontend section, and take a look at the seed card ng micro-frontend. And as you can see here, it's importing a piece of JavaScript, which is built from an Angular application, and everything is rendered into the ng seed card details custom element. So this custom element, again, is defined by the web component spec. There's nothing proprietary or special about it, and Angular knows how to render into that element inside the DOM. So now we've got a foundation in micro-frontends. It's time to move on to talk about Java for Kubernetes. We're at the J4K, Java for Kubernetes conference, and we haven't really talked about Java or Kubernetes yet. So in the next sections, we'll talk about how Kubernetes enables us to deliver on this architecture and deliver on the promise of modularity, and the role of Java microservices and Quarkus and serverless architectures that can really drive a lot of capability and a lot of functionality at enterprise scale inside of an architecture like this one. So we're going to talk about a few key features in Kubernetes that really can capture the value of our micro-frontend architecture. And those features are routing and ingress. So the ability to control where traffic goes and how traffic is delivered to your underlying services has a lot of value in a micro-frontend architecture. The ability of Kubernetes to granularly scale applications and scale pieces of applications is really valuable, especially as you think about the kind of information that you can get from the front end in a micro-frontend architecture in terms of traffic patterns and where your traffic originates. We'll talk about discovery and deployment automation, and this is both with respect to custom resource definitions and custom resources in Kubernetes, as well as the role of an operator in a micro front-end architecture and some of the power that that can give us in creating and deploying and managing these applications. And then the last one is the potential for a service mesh to really deliver dynamic functionality from a UX perspective inside of a Kubernetes architecture. So we'll talk a little bit about potential opportunities to build things for A/B testing, for canary deployments that drive functionality all the way out to the user experience layer, and things like that that really can make an application more dynamic and take full advantage of the modular architecture that we're creating on the front end, as well as the modular architecture that we already have in our microservices. So the first capability we'll talk about that Kubernetes gives us in our micro front-end architecture is routing and ingress. And it seems like a simple thing, but routing and ingress provide a lot of power in an architecture like this where we want to really strongly decouple different parts of our application. So by using routing and ingress in Kubernetes services, we're really truly able to decouple our UX from the underlying implementation. And we can even make relative path API calls from our micro frontends to the underlying services. And this gives us a lot of portability. So the micro frontends themselves don't have to know anything about where they're deployed. They don't have to know anything about the underlying architecture that's serving them data. They have the ability to make a relative path API call from whatever app they're deployed in, and then they get their data back because Kubernetes takes care of the routing. This routing and ingress also gives us the ability to create strongly contract-driven development and deployment architectures. And it's also really testable, so it's fairly straightforward to test these kinds of architectures because everything is decoupled and contract-driven at that network layer. And it's something that Kubernetes makes very easy and transparent for a micro front-end developer and also for a microservice developer. So it's a simple thing, it's a core Kubernetes piece of functionality, but in a micro front-end architecture, it gives us a lot of the portability and reuse that we talked about when we talked about some of the benefits of this architecture. So now I want to jump over to Kubernetes and take a look at what this looks like in practice. So how do these services end up looking when they're realized, and how do the micro frontends make the calls that they actually make? So we'll jump back to our sample application and we'll take a look at the dashboard again that shows us a few different micro frontends that are making some API calls to fetch data from the back end. So if we look, we have our 3 micro frontends and then the 4th micro frontend, which is our table. And if we look at the network traffic, we can see that the micro frontends are making a relative path API call, and then that's getting routed to the underlying microservices. So if we jump over to OpenShift and we open up the routing that we have deployed there, we can see up here at the top that we have this quick start sales demo with a relative path API call mapped for those micro frontends. And then that is calling the underlying service inside Kubernetes. So our micro frontends don't know anything about the underlying service. They don't know anything about the top level domain where they're deployed, but they have the ability to make that relative path API call like /credit card transaction, like /credit card, like /checking, and then get the data they need back. And it gives us a lot of flexibility on both the front end and the back end to swap out functionality and redeploy functionality as we need to. A micro front-end approach also gives you a little bit more information over how traffic arrives to your microservices and how your microservices will receive traffic based on the way that your user experience is designed. So a micro front-end architecture can both benefit from Kubernetes scaling and also provide you more information to identify how to manage the scalability of your application. So for example, you can do client-side caching on a per micro front-end basis. So if one micro front-end accesses a lot of static data or data that's not likely to change, you have the ability to cache that on a per micro front-end basis without impacting the rest of your application. You can also track and manage traffic at the component level at the UX layer. So rather than just managing traffic at the microservice layer, you can understand that traffic origination at the UX layer from your micro front-ends, and that'll help you make optimization decisions. You can also optimize traffic without impacting your entire micro front-end application. So we can take advantage of that independent deployability, independent optimization. So if there's a piece of the application that's built in a micro front-end, we can optimize that single piece of the application without having a lot of side effects to the rest of the application. And then finally, you can scale the services you need based on where things are rendered. So if you know certain pieces of your application aren't accessed very often, or if certain pieces of your application are less likely to be accessed based on traffic patterns, you can change your scalability plans rather than a one-size-fits-all for all of the services inside of a single application. So for example, if we take a look at our seed bank application and go back to the home page, if we know, for example, that 80% of our traffic is going to be going to checking and savings based on UX level tracking, based on what's happening at the user experience layer, that will inform the way that we scale and manage the scalability of the microservices that serve those micro frontends. And for example, if insurance is only accessed on 10% of our traffic, we can know ahead of time that the micro frontends and the services that support them in the application will need less instances or fewer instances in most cases. But the key is micro frontends benefit really significantly from what Kubernetes provides from a scalability and automation perspective, because they're built to take advantage of the underlying modular architecture that we've already built using our microservices and the traffic management patterns in Kubernetes. Another area where Kubernetes can provide a lot of value is in discovery and deployment automation. At Intondo, we do this via a Kubernetes operator, and it delivers a lot of value to a micro front-end architecture. In particular, our operator has the ability to automate the creation of Ingress to serve your micro frontends, and that allows your micro frontends to work across multiple applications out of the box. Your micro frontends don't need to know anything about where they're deployed or where they're going to be running. You can set up appropriately scaled microservices. So just a minute ago, we talked about scalability and how micro frontends can give you more information to optimize how your microservices are scaled based on the way your application behaves. And you can set up an operator or Kubernetes in general to automate the deployment of your microservices in a scaled way that matches your expected needs. And you also have the ability to deliver automated integration for platform services like identity management, logging, and anything else that you need from an infrastructure standpoint. A lot of the people here are probably used to using the operator to deliver those kinds of things for backend architectures and for microservice applications, but those can benefit micro front-end applications as well. So for example, if we switch over to our demo application and we take a look at the login here is an example of micro frontend. It's a very simple micro frontend that's redirecting to platform services for identity management. So in this case, we're redirecting to Keycloak, providing the access level and access controls for both our backend and frontend microservices. So our micro frontends are able to get access to a token via Keycloak and then use that token to interact with the platform. In this case, making direct API calls to the services that are running in Kubernetes, but that can be going through an API gateway or the other piece of infrastructure that you use. And so the ability to inject platform services all the way out to the UX layer is a big benefit of Kubernetes and a big benefit of the operator pattern for adding automation and discovery to your Kubernetes applications and to your micro front-end architectures. And the last concept we'll talk about from a Kubernetes perspective is the potential of a service mesh to add a lot of really dynamic capability to a micro front-end architecture. So with a service mesh, you can take advantage of traffic management to allow different versions of the same micro frontend to render in the same app or on the same page. So for example, if you put the decision making about which micro frontend to render behind a service mesh, you could use the routing and traffic management to make decisions about which one should render when and how they should render. And the micro frontend architecture supports rendering the same micro frontend on the same app or in the same page. And so Kubernetes and a service mesh would have a lot of benefit in that potential architecture. The other thing you could do is provide switching about which underlying microservice provides data to a given micro frontend. And you could do this with any application using a service mesh, but in micro frontends, you get a little bit more control over which part of your application, which part of your user experience you're overriding. And you also get the ability to really control which parts of your application need to know anything about the service mesh or need to know anything about the type of testing that you're doing. And then micro frontends allow you to deliver an experience with the mesh without impacting your entire architecture. So if you have a front-end monolith and you want to take advantage of underlying capability in Kubernetes or in the service mesh, to some extent, your entire front-end monolith needs to be aware of what's happening or aware of the changes you're making there if there are impacts to the front end. While on a micro front-end architecture, you can take a small piece of your application, experiment, figure out the patterns that work for you, and then deliver that capability wider in a shared way by using the platform distribution capabilities you get from an operator or from other things that allow you to configure an entire application. Another really interesting potential use case of a service mesh and micro frontends on Kubernetes is changing the way that applications are composed. So micro front-end applications are ultimately put together and then rendered to the final user as a single whole. And a service mesh could give you the ability to do A/B testing at that micro front-end level. So if you put the micro front-end choice behind a service mesh and then use traffic routing patterns or use information about the user or session awareness to make a decision, you could actually change which micro front-end renders to a given user or to a given page based on dynamic information. And so you could do things that you see in a lot of DXPs kind of out of the box using Kubernetes and a micro front-end architecture. So now I'm going to change gears a little bit and talk about the role of Java in our micro front-end architecture and how the Java world and recent changes in the Java world on Kubernetes can play a big role in how we develop and build our micro front-end architecture and really change the way that our micro front-end architecture behaves in production. So from a Java perspective, we're going to talk about a few different things. The first is the ubiquity of Java-based microservices and the ability to quickly deploy new capability into this architecture. The role of templating and code generation via tools like JHipster to automatically create capability that matches our architecture and that can be deployed out of the box. The role of serverless Java with Quarkus, in particular, the role of serverless paired with micro frontends has a lot of potential to change the way some applications render and behave from the backend. The way backend for frontend can work with Quarkus, we'll talk a little bit about backend for frontend or BFF as a pattern and why Quarkus is a great match for that type of architecture. And then we'll talk about organizing full stack capability as a deployable unit. How do we take something that represents a business requirement, package it up, and then make it something that we can deploy and reuse in many applications using both Java and micro frontends. So now we'll dive in and talk a little bit about how Java microservices can enable and really drive functionality into our micro frontend architecture on Kubernetes. As everybody at this conference probably knows, there are a lot of options for packaging up and delivering your microservices, including things like Spring Boot, Quarkus, and Micronaut. All of those things can be used inside of this architecture, so you're not constrained to a single set of functionality. Quarkus in particular has some functionality that's really interesting that we'll talk about as we get further into the demonstration, into the presentation. And also note the code that we have shared for the demo app uses a set of Spring Boot microservices. So you have the ability to go out there, download those, install them, and see how they behave inside this architecture. It's also important to note that a single Java microservice can provide data for multiple micro frontends. So you could have one microservice dedicated to checking, for example, and then have 4 or 5 micro frontends that represent the user experience for that microservice. And the goal is to use micro frontends in that case to accelerate reuse of a full stack. So basically you take your microservice, the set of micro frontends that go on top of it, and then treat that as a bundle or a set of capability that you can reuse quickly across applications or customize depending on what you need to do for a given application. So let's jump over to OpenShift and take a quick look at how the Java-based microservices are deployed inside of our demo system. And again, you can go out and deploy these yourselves using the instructions out on GitHub. So as you can see, we have this credit card plugin, we have a checking plugin, we have a savings plugin. All of these plugins are Spring Boot-based microservices built for a Nintendo application. If we take a look at the logs, it's a standard Spring Boot app exposing an API, and then that API is consumed by the micro frontends. And if we jump back over to the application, we can take a look at our micro frontends. And again, these are all using different microservices, but in principle, you could have them all calling the same API or the same microservice on the backend. So you have a lot of flexibility for how your applications, for how your micro frontends access the microservices and access the data that they need. And in fact, you don't have to use microservices here. These micro frontends could be consuming data from a legacy monolith on the backend or even a dedicated monolith on the backend that you built intentionally depending on your business requirements. So the architecture itself has a lot of flexibility, but Java-based microservices are a way to really package up and deliver reusable functionality in a quick way inside of a Kubernetes micro frontend architecture. Next, I want to talk about the role of templating and standardization in this architecture. Micro frontends and microservices are really ripe for capturing value from templating. And templating gives you the ability to capture common patterns or enterprise level standards, the way that you do things, the way that you build micro frontends, the way that you build microservices, and then set them up so that developers are accelerated or out of the box with all of the functionality that you need. At Intondo, we use an open source tool called JHipster, and we use JHipster blueprints to customize the way that we build micro frontends and the way that we build microservices for our end users and our customers. Intondo is also working on creating a JHipster Quarkus blueprint that includes micro frontends. So our goal is to add to that open source project and deliver new functionality that allows developers to very quickly create new capability and new functionality. And in fact, in the sample application and the microservices that we just looked at, the microservices and the micro frontends were created using JHipster and using the templating engine that Intondo provides out of the box. So now let's go one level deeper on templating and component generation and the role that can play in a micro frontend architecture. The picture you see here is specific to what we do at Intondo, but the pattern could be applied anywhere. You could take advantage of your own templating engine or take advantage of a customized instance of JHipster to do this inside of your micro frontend architecture or inside of your microservice architecture, however you want. Over here on the left, we have the component generation flow. In this case, when we say component, we're talking about micro frontends and microservices. Those microservices are runnable out of the box. So when you think about templating, one of the best practices is make sure that whatever your template generates is runnable. Make sure that a developer can start with something that's working and functional and then add to it as they need to. It's also important that what you generate from a templating perspective in this environment is built to be edited. Code generation as a practice has a bad reputation because a lot of times it's not built to be edited. So our goal and we think the best practice is to build things or templatize things that are then meant to be changed and customized by your developers. So in the second step, once we've generated our components, we're pushing those components to standard repositories. So we're using things like Git and Docker. And again, this is another best practice. Make sure that what your template generates fits into your tool chain. So you push those things to Docker registries, and then we have the ability to bundle those up, including front-end and back-end capability, and then deploy them across many applications. And again, this pattern could be applied whether you're using Intando or some other micro front-end practice. But the goal really from a templating perspective in a micro front-end architecture is to identify a set of patterns that matter to your enterprise, and then reuse those patterns or stamp them out in a factory style so that your developers are always following the rules that you expect and always following the enterprise style and enterprise patterns. And then that way whatever you build is going to be ready to go to production and going to be ready to go into your staging environments when you're ready to integrate and test your applications. So one potential valuable pattern for applying micro frontends and microservices is to think about how you package common capability. So how do you take a bundle of micro frontends and microservices and create deployable packages from them? So for example, you have this alert icon with its microservice and its database, over here in the picture on the right. This could be packaged up in something that you reuse across many applications. You can make alerting and the associated microservices and the associated micro frontends that go with it sort of an enterprise toolkit that you can deliver into many applications. So one of the things as you get into a micro frontend journey and a micro frontend design to think about is how do you want to design your packaging and metadata so that you can deliver a set of functionality to a new application or to a new user in a very quick way. And that's always been the goal of microservice architectures, is to enable reuse and agility, and the same thing is true of micro frontends. So now that we've talked about templating as a pattern, I want to talk about another potential pattern where micro frontends and microservices can deliver a lot of value, and that's backend for frontend. And backend for frontend, or BFF, is a way to create very small, lightweight pieces of functionality that deliver data depending on the experience type of the user. So that could be a mobile user, that could be a desktop user, that could be for internal users. It could be depending on the type of experience that user expects to have. And the goal is to create very, very, very small services that deliver only the data that type of experience needs. These aren't meant to replace your APIs. These aren't meant to even be APIs in general. They're meant to be dedicated translation layers or dedicated pieces of functionality just for that piece of experience. And there's a lot of functionality in the micro frontend and Java world that can assist in creating this type of architecture. So if we look at this picture on the right, you can see we have this mobile, and then we have our mobile BFF, we have desktop, and we have desktop BFF. All of those things are dedicated experience. And in a lot of cases, those are stateless. So they're things that you build that don't store any data. All they do is provide translation from your API layer, which maybe your API layer is complex or your API layer is legacy, and you need to provide something different. So they provide that translation and then deliver that experience out to the end user. And the value that micro frontends can provide in that environment is that micro frontends make BFFs not an all or nothing proposition. You no longer have to provide a fully BFF-driven architecture, a fully BFF-driven user experience, because you can build a BFF for a specific micro frontend. Maybe 80% of your app is the same across desktop and mobile, but for some piece of your application, you need to provide a really dedicated experience. You can provide a BFF just for that one MFE, just for that one micro frontend, and then the rest of your application can continue to use your standard APIs and microservices. And again, that takes advantage of some of the functionality we talked about in Kubernetes before with the dedicated ingress and routing and the ability to really control how traffic is delivered to your underlying services. Quarkus paired with micro frontends are also a really key driver for BFF stacks. So Quarkus gives you the ability to create really, really lightweight server-side components, which is a requirement for BFFs, because if you're creating a lot of BFFs and they're heavy, you're eventually going to consume all of your resources, or it'll be very expensive to operate. So when you're creating your BFF on the back end, it's important to think about very lightweight, cost-effective pieces of functionality, because they're going to be very dedicated, and you're still going to be using your underlying infrastructure and your underlying APIs. So to summarize that, micro frontends and Quarkus and lightweight microservices in general are a great way to deliver dedicated user experience, kind of using the power of the Java ecosystem and some of the newer micro profile functionality that's coming out into the market today. So I want to take a minute now and talk about a little bit about modernization and how you can apply some of these practices and patterns to existing applications or to existing infrastructure. It'll be rare that you have the ability to start completely clean and have the ability to do all of this from scratch. So from a modernization perspective, one of the things that we like to think about is the Strangler pattern and the ability to take small pieces or dedicated pieces of an application and move them bit by bit. And both microservices and microfrontends are really, really well suited to that type of pattern. If you're thinking about how do I go from my microservice-oriented architecture with a monolithic front end to a microfrontend-oriented architecture using microservices on the back end, or how do I go from my full-stack monolith to something that takes advantage of these new architectures? And the way to think about that is as the Strangler pattern. And what the Strangler pattern says basically is take a small piece of your application, identify a piece that you can carve it out, and do new things in the new way. And this gives you the ability to add small bits of modern user experience on top of legacy infrastructure. One of the use cases that we take to a lot of customers and to a lot of enterprises is to leave their legacy infrastructure in place and then use some of the patterns we've talked about today to deliver modern UX. So you get out of the kind of slow, legacy, bad-looking UX and use microfrontends as a way to add new capability on the front end without having to change all of your infrastructure. So carve out key functionality and then demonstrate early business value. So part of the Strangler pattern and part of the benefit of the Strangler pattern is to really have the ability to put new value and new capability in front of your user very quickly, rather than having to go through a big bang rewrite. So from a reuse perspective, you can approach this from the back end, you can approach this from the front end, or you can approach them at the same time. But it's really, I think, a good pattern to think about how do you take small pieces of functionality or small pieces of an application and then apply the power of the modern Kubernetes tools that we've talked about and the modern Quarkus and Java-based tools that we've talked about to really deliver new capability. And it's also really interesting to note that all of the Kubernetes tools we talked about and the Kubernetes patterns that benefit micro frontends are really well suited to a Strangler approach as well, because the routing and scalability and things like that also help you modernize an existing application without tearing everything apart all at once. So as we wrap things up here, let's talk a little bit about some best practices and pitfalls in this kind of architecture and some things to be aware of. I read an article recently that said there are no best practices in software architecture. Everything is a trade-off. And to some extent, I think that's true. It's important that you understand your environment and the things, the challenges that you're facing, and then apply the best solution that fits the challenges and objectives that you have. So with that in mind, we'll talk about some things to be aware of. But again, map these to your environment, your problem set, and what the tools are giving you, and what the tools are telling you about what you can do best. So the first thing we'll talk about is organizational readiness. One of the best practices and one of the most important things about micro frontends, and I think about microservices as well, is to make sure to structure your team for the outcome that you want. So build your teams in a way that allows them to get the most out of the architecture and the most out of the tools that you've selected. And so from a micro frontend standpoint, we talked about independent delivery. Make sure your teams are enabled to develop and deliver independently. Make sure they have everything they need to get their application or their functionality to production. Make sure responsibilities and goals are clear. So make sure that a group of people has a clear set of responsibilities. Those responsibilities are well defined. We talked a little bit about API contracts as we went through some of this in contract-driven development. It really helps to make sure there are good contracts between teams and the teams have agreed what those contracts are. And then you have the ability to allow those teams to evolve and innovate on an independent basis. And then the last thing is make sure your business requirements are built with modular delivery in mind. So you have the ability in these modular architectures to do new things and to deliver in new ways. But if your business requirements are all focused on a monolithic top-down, define everything at once type of approach, you're going to have a hard time getting the most out of your tools. So make sure that from a business perspective, everything is aligned as well, and that the way you build and deliver your requirements into your team fits with the types of capabilities, your tools, and technology are giving you. From a pitfall perspective, one of the things to keep in mind is that premature optimization in this type of environment can really hurt you. So the general instinct from developers and development leads in particular is to find common things and then share them, create shared libraries, create shared utilities, create utility projects, create common utilities, create common places to put code. That can be a downfall in this type of architecture. I think it's true of both micro frontends and microservices. So when you have to make a decision, err on the side of repeating yourself rather than sharing a code and libraries in your micro frontends. The goal here is to really create that independence, to really create the ability to innovate and move quickly in a small group way. And if you focus on creating shared libraries, eventually you're going to gridlock yourself and you risk creating a distributed monolith. Make sure to value independence and deployability of your code oversharing libraries and sharing things between libraries. So the goal here really is to create that independently movable, independently innovatable piece of code. And so that should be your focus when you're making these decisions. And then the last one is take advantage of deployment automation to really inject capability where you can into your services. So rather than creating shared libraries, inject things from the environment and create contracts and services rather than creating shared code. And then use Kubernetes and the power of operators and the power of the environments that Kubernetes gives you to provide that as part of your infrastructure rather than creating code or libraries that you bundle up at compile time. Another best practice is to really focus on automation. This is probably true of any architecture that you have or any test architecture that you have if you're building an application today. But having automation and focusing on test automation is especially important in a highly modular architecture. So you need the ability to deliver continuously, and you have to make sure that test automation is strong enough that you have the ability to put what you create in front of the end user. So focus on testing at multiple levels, focus on live testing and deployed testing, and make sure that your automation provides enough confidence that you can move pieces of your architecture independently and know that you're not risking a huge amount of problems when you get to production or where you get into your staging environment. Another important piece of this is to focus on contracts and make sure that your contracts are well-defined and well-tested and testable. So build testable contracts and make sure that your micro frontends and of course your microservices as well have those contracts and have those contract level tests. If the contracts are right, then it makes your job a lot easier when it comes time to find a problem or solve a problem. And it's a big piece of getting the maximum value out of your test automation and out of your test infrastructure. Another potential pitfall here is overzealous application. So like we talked about, every architectural choice is a trade-off. And like all patterns, micro frontends aren't a silver bullet. They aren't the right solution for every kind of application. They aren't the right solution for every kind of environment. So you need to take a look at what you have and where you're going. But if you over-apply the concepts, you have to be aware that you can over-fragment your application and create things that don't have value. And this is true in microservices as well. And there's lots and lots of literature about the right size for microservices and how to size your microservices and what should be a service and what shouldn't. A lot of the same strategies and techniques apply. So as you build these things, it's just something to watch for. Watch for over-fragmentation and make sure you're not creating a distributed monolith. So you're not creating a whole bunch of little tiny pieces that are actually all one giant piece because they can't move independently. So tight coupling in this environment is a killer. And look for applications that benefit from the strength of the architecture. So if you have an application that needs independent, you have something that is going to evolve and be dynamic, which a lot of applications do. If you have an environment that's going to benefit from reuse and standardization and the ability to template what you do, then this type of thing is really a good fit for you. And it's a good fit for a lot of applications, but there are definitely cases where you need to take a look at the environment and what you're doing and your ability to deliver on the promise of the technology to make sure that it fits for your applications. So for example, if we switch back over to the sample application that we looked at, some of these alert icons, you could build a micro frontend that represents each one of these icons individually. But in a lot of cases, that would be too fine-grained. It would be too fine for what you need to do. And so this is a single micro frontend that represents an alert bar. And there's no golden rule here. You have to look at your capability, your environment, and decide what should be a micro frontend and what shouldn't. One of the things to think about when identifying what should be a micro frontend is to make sure that things have a business purpose in isolation. So if you take this card here that we have in our application, this has an isolated business purpose. It provides a summary currency value to our end user. It interacts with a microservice. It has its own API calls. It has its own utility. So we can point to that card and say, okay, this thing by itself has an identifiable business purpose. I could explain to somebody what this does by itself. If you're looking at a micro frontend and you have to have context in order to explain it, maybe it should be part of a larger micro frontend or larger part of your application. And so think about identifying business purpose and applying micro frontends to an identifiable business purpose and an identifiable outcome. So think about how you describe these things to end users or describe these things to people outside the team. And if you're able to do it, then it's a great idea to consider it as a micro frontend. And then the last best practice we'll talk about is injecting platform services. So make sure that the things that you can provide as common infrastructure or treat as infrastructure are available to your entire application stack, whether micro frontend or microservice. So for example, in Nintendo, we inject identity management. We inject Keycloak into all of our applications and everything has a common view of identity. So in that case, we have a service, we have a set of capability that looks like infrastructure, behaves like part of our infrastructure, that everything is able to make use of. Identify common patterns for deployment. So make sure that you're deploying all of your micro frontends in the same way. And to the extent possible, make sure you're deploying your microservices in the same way. Even if they're different libraries, different languages, you can mix and match Quarkus and Spring Boot and Python and still have a common set of patterns in the way you expect your microservices to arrive in your environment. Identify common rules for things like scaling and the way that you scale and when you scale and what requires scaling. And then focus on bundling and reuse. We talked a little bit about packaging these things up. Make sure that you have a common way to package this capability up, no matter the technology stack that you choose. So it's really important to focus on a set of capability that you can deliver as infrastructure, and Kubernetes really it adds a lot of value in that space. It provides a lot of intelligence in the infrastructure. You can use things like custom resource definitions and custom resources to discover assets and perform automated tasks. The operator framework provides a lot of infrastructure and capability as well. So when you think about building these things, identify the things that can be part of your infrastructure and behave like part of your infrastructure, and then inject them to your business-facing application components like microservices and microfrontends. And so to summarize everything that we've covered here today, microfrontends are great for building a modular architecture ready for cloud-native application development. They decouple UX and business logic. They give you the ability to really innovate on both fronts independently. Kubernetes native and containerized deployment is a really important part of delivering on the promise of this architecture. Focus on a component repository for reuse. So build things and package them up for reuse. Focus on an agnostic approach to infrastructure, channels, and devices. So how do you package up your capability in a way that allows your tool chain to adapt and that allows your developers to pick the tools that are right for them? And then focus on an API-driven and extensible approach. Make sure that you're defining contracts between your micro frontends and make sure that your contracts are well-tested and automated. So from a business perspective, the goal of a micro frontend architecture is to get you to production faster and then allow you to innovate in market once you're there. You can use any type of capability you want. So if you're making this decision as a business user, your developers can choose the tool chain that they want, they can choose the toolkit they want, and it's going to support this kind of architecture. Micro frontends are based on a modern full stack, including all of the Kubernetes stuff that we talked about and things like Quarkus. Standardize what you do from a microservice perspective and use templating. It can deliver a lot of value in the way that you standardize your applications and your capability as the business creates new functionality in new applications. Build for Kubernetes, and then use open source and standards-driven approaches to make sure that what you have is future-proof, or at least has the ability to evolve as the future evolves. And last thing I'll leave you with is that it's really important in this type of architecture, and really in any software architecture, that the entire business is focused on the same goals and understands the value proposition of what you're doing. So make sure that your business teams, your design teams, your development teams, and your operational teams all have the ability to innovate and move independently and move quickly. As we install these agile life cycles, as we install the ability to deploy and change things in an automatic or fast way, everybody needs to be on the same page so you can deliver maximum value to your end users. Thank you for listening. We look forward to seeing what kind of questions you have in the chat, and have a great day.